What's that?
Oh, here we go. So I was taking apart my V2 Jubilee. I was looking at, I was replacing the Z couplers because I was like, let's try this like springy Z solution with the little 8mm ball. And so that's been working really, really well. But in the process, I noticed that the rust bearings are actually worn out. It's really it's very interesting. Let me see if I can dig out the picture. Oh, I see that it's uploading the picture.
What bearing was worn out?
Say what? Oh, the couplers. So one of them is worn, is totally worn out. The other two are okay.
The plastic one.
No, the metal ones. So hang on. Let me. Here we go. Here we go. Picture time. Oh, hey, that looks great, by the way.
Oh yeah. Yep. That's not surprising.
So just one out of the three. So I think a longevity fix is going to be thrust bearing.
Yeah, I've been thinking about the kinematics and the loading of
Mm-hmm.
the proposal you had
Mm-hmm.
with the steel, the ball bearing, and the and whatnot with
Did you
the spiral,
Oh, the helical one.
the helical cut. Yeah. Um, and so I was thinking about where you're putting the thrust bearing on it and um, where the load forces are.
Uh-huh.
Right. So you've got you've got a vertical shaft coming down, right, into the coupler, and it's going onto a ball bearing, right, and that
Well, it's
ball
going onto a
bearing,
ball.
it's going onto a metal ball, right, but the upper portion of the coupler is still clamped to the lead screw, right,
Mm-hmm.
and then the ball bearing is resting inside the coupler, or is it resting on the motor shaft?
Oh, yes, that is a good point. Let me think about it for a second.
Um,
Uh, in one case, depending on where you put it, it could be resting on the motor shaft.
I don't know if what the interior of that coupling of that spiral coupling is.
You would need a
If it
spacer.
has a okay,
You would need a spacer.
okay. Well, what I was getting at is what's on the inside of that coupler. Is
Exactly,
it
because otherwise you're pushing onto the shaft again.
right? And you're pushing onto the shaft, but then you're running into the same. You're transmitting all the loads through the coupler. You in order to really give a. I guess the thing I'm getting at is if we're going to put a thrust bearing on here at all, take a to let the coupler do its job for handling misalignment, right? And to decouple the motor from the shaft as far as any vibrations or anything like that, right? Um, the coupler, there needs to be a thrust collar above the coupler that transmits to the frame. And if we need to not be constrained in the XY, that's fine. But in order to not load the motor and to not load the coupler, the thrust bearing has to be above the coupler.
I gotta think about it. I think you're onto something. I still processing.
No, I don't think I'm. I mean, definitely think about it. Definitely challenge the concept here. There's a reason, and the reason I say that is there's a reason ball screws have their bearing blocks manufactured the way they do. And
Oh,
there's a
okay.
theory that a ball screw also has a thrust collar machined into it. I think I've got. I have no idea what's going on here.
Yeah. Okay. So on a CNC, the bearing
I mean,
block
the
on
loads
the
are a lot
motor.
different.
What's up?
And the loads are a lot different by several orders of magnitude.
Yeah. But I mean, like, I will mention CNC, that linear stage for, let's say, the table, it is over constrained. That's fine. But yeah, so the CNC is actually still over constrained because the nut that is connected to the table is rigid. There's no flex there. That said, it could be that they actually want it that way because they want that it makes alignment difficult, but it's very, very, very rigid because for that reason. In our case, we're using couplers in order to make it such that the user who assembles it doesn't have to perfectly align the machine. They can get close, and they will still get good enough results. And I think that's a fair way to use them.
Yeah, I mean, would there be one other thing is to look at a lead screw? I mean, a motor with a lead screw on it.
That has the same problem because in our case, the constraint is applied it's being applied from the z-axis rail and the nut. The printed part that rigidly connects the two of them, that is where you have the constraint. And that's actually, in a printer configuration, I would say that is where you want it. Because the lead screw can be bent ever so slightly. And if you constrain the XY position of the lead screw rigidly, all that bending, that wobble of a not perfect lead screw is going to transfer into the bed. The cool thing about not doing that is that the lead screw, by constraining the travel instead of having the lead screw be the constraint, is that the lead screw can be bent, but because the travel is constrained up and down, you still get a good bed from a not totally perfect lead screw.
Yeah.
So far, so good.
Oh yeah, no. Again, I know we've been through this. I'm just trying to see where the wear points are.
Yeah, because the issue with the motor. Go ahead.
And where the wear points are, and where we're able to use a coupler to allow for that misalignment, right?
Yeah.
And so the coupler would allow for the misalignment, but we need to, in order to do so, we need to support the lead screw above the coupler.
Yeah. So I think you've brought up something which is the ball screw. Sorry, not the ball screw. The ball inside of the coupler that I suggested earlier is still missing something because of what you said earlier. You're absolutely right. When you put the weight, when the z-axis applies weight, it's applying weight onto the shaft of the motor. Its weight is going down, which is the whole thing we're trying to prevent in the first place. So this doesn't. And the way to fix that is, thankfully, the bottom of the coupler is counterbored because it's essentially drilled out to be the dimension of the wider one. So we just put a spacer, and then we're fixed. That problem goes away.
Well, okay, and then at that point, the coupler is then compressed.
Then so we put a spacer in, and then the pressure goes into the bottom part of the coupler, which is pushing on the thrust ring, which is pushing on the case.
Yes, but the coupler is also rigidly connected to the motor shaft.
Well, no, because it can still flop around. It can still bend over with the ball.
It's rigidly connected to the motor shaft in the Z direction.
Well, no, because the ball is in there, the 8mm ball.
It's not clamped onto the motor shaft.
No, the 8mm ball just rests in the pocket.
Okay, right.
Yeah.
So look at a force diagram for the spiral clamp. It's clamped onto the motor shaft, right?
Mm-hmm.
It's not keyed onto the motor shaft with axial travel. If it were keyed onto the motor shaft with axial travel, then your thrust bearing assembly would be great.
Wait, say that again.
If the coupler were keyed onto the motor shaft, but were allowed to travel in the Z direction, then your thrust bearing assembly at the bottom would be fine. But you're physically clamping the coupler onto the motor shaft, right? You could assemble this with a gap between your thrust bearing and the bottom of the coupler, and it would still operate. Correct?
Hang on, I'm just thinking about it. You could assemble it with a gap between
the lower portion of the coupler, the bottom of the coupler, and your thrust bearing assembly that you had with the printed part and the little thrust bearing, right?
Yeah, that would be incorrectly assembled.
Yes, I don't disagree, but it could be done, right?
Mm-hmm.
And even if you did correctly assemble it, how do you unload the motor bearings so that the motor shaft is floating inside the stepper motor?
Yeah. So
You see what I'm saying?
yeah. So I guess in the design as is or as proposed, I think it's basically the same. Well, sure. I guess it's the design as proposed. Yes, it is. It is possible for the motor. It is possible. Okay, so when you push down on the coupler from the weight of the bed, you are pushing on the motor shaft, but you're also pushing back from the thrust bearing. So even though the vertical weight is to some extent, it is coupled to the motor shaft, and the force is coupled vertically, it's not able to deflect because the thrust bearings are pushing back.
Right. I'm just saying you're still rigidly cut. You're still effectively rigidly coupled to the motor.
Well, it's not rigid because you can flex it, but you're not. What is true is you're not constraining it. You are constraining it XY. Through the motor. Does that make sense?
Yeah. Yeah.
So that's the problem that this setup. None of the setups we've come up with so far fix that.
Well,
there is a way to fix that.
What if we took my thrust gauge, right, and instead of the bushing, if the bushing were instead of 8mm were say 9mm, 9.5 on the inside diameter.
Okay.
So if this bushing here, maybe careful. So if this bushing here were some dimension of Z lead screw plus X, right? You see where I'm going?
If dimension were
the diameter, the inside diameter of that bushing were the lead screw plus some clearance.
Okay, so yeah, if it were loose, okay.
If it were loose in there, and then we still had the collar around the lead screw that were resting against that bearing, or against that bushing, it would be available to translate in the XY, but it would be constrained at least in the downward Z.
Correct. Yeah.
And that, I think, would take all of the weight off of our couplers. It would take all the loading off our couplers except for what they are designed to do.
Yeah.
Or the alignment.
The only issue is that it's still, if it does move in XY, it's still scratching the bushing, but maybe we don't care about that.
Yeah, and that's an oil impregnated bronze bushing with a stainless steel collar on it.
Yeah.
Bushing is going to work.
I feel like there's a way to do this with flexures, but I haven't thought of a way that I like. I was thinking about taking the Z plates out and replacing those with a cutout for flexures so the whole motor could move in XY. But that also seems like a lot of work.
Yeah, and how do you keep it from moving in? I mean, you can, but yeah, it becomes, you're increasing complexity, and you're having to come up with custom parts.
Well, it's just laser cut Delrin.
Yes. Which, by the way, my laser's not ready yet.
Oh. Darn.
No, I've got some alignment issues that I'm.
Yeah, those are a pain. But once you get it up and running, you don't have to worry about it.
Well, I'm finding that it's yeah. My mirror one mount, I think, was incorrectly assembled.
Oh no.
I mean, that proportion where the mirror is looks fine, but the base, I'm looking at it going, that doesn't look like it's right. And by the way, if I breathe on it, it moves.
That's not good.
Nope.
You're not supposed to breathe on something and have one of those and have it.
What's that?
That's not good.
Yeah, it's like really floppy. So I kind of need to take it all apart. It's like, and it's such a big machine. Oh my God. I have to it seems like walk around, hit the pulse button, walk around. I have no idea. Have to all right, was that dot there before? Because I can't put eyes on where the dots are, where the mirrors are, and still reach the pulse button.
Yeah. Schrodinger's laser cutter.
Plus I need to work on some. I think I need to check the mechanics. It's got 10mm belts on it, and they don't look like they're fiber reinforced at all. You know how, just the vinyl belt.
Oh no! Yeah.
I can probably replace the belts with 12mm gates. I think would probably be fine. I'd have to recalibrate the steps. But that shouldn't be, but so hard. It is running a Ruida controller. So
Okay.
I may just have to change some pulleys, or some idlers, but yeah. But if I put 12mm Gates power drive belts on those, they're not going in, and I'm gonna have a lot less backlash. I almost want to take the entire upper housing assembly off, which would be ridiculous, by the way.
Yeah. It would be a work. It would be an unpleasant amount of work.
Well, not as much as you might think, but it's only like 12 volts. After you take the lids off, it really is only 12 volts. But yeah, because it's like the amount of clearance to get to the mirrors is like ridiculously small. You're working through a little tiny door to get to mirror 2.
Yeah, doesn't sound like fun. Ugh.
It's fun. But anyway, so I have successfully printed a multicolor print. I am not at all happy with my current build plate or my build surface because I've got a ton of wrinkles and stuff in the PEI sheet. Even though I put it on right accordingly, it's like tear back one corner and then lay it on with putting it onto a squeegee, and it's like, why did I not? Isn't there a wet method for putting these things on?
Yeah, that's hard. What plate do you have? Is it a build tack?
No, it's the steamy CNC one.
Okay.
It's like it wasn't.
Oh yeah.
Yeah.
That one was difficult for me too. If you don't like their sheet, their PEI sheet, which is quite glossy, BuildTak has one that, in my experience, was easier to apply than the Senior CNC one.
Well, I need to get either another flex. I can just order it from Tiny Machines. They have a 12 by 12 with a PEI already installed.
Oh, okay. But yeah,
Or
how much is that? Wait, how expensive is that?
Not as much as you might think. Hold on. Let me check
Tiny Machines.
I mean, they gave me a deal on some slightly damaged build surfaces. So you can get a 310 by 310 for $40.
It's pretty good.
It is currently sold out.
Darn, too bad they don't have 12 by 12.
Well, that's 305 by 305.
Yeah. Which I'm starting to believe that it was, I don't realize how that's so uncommon, but I suppose it is.
Well, the 310 by 310 is made common by the Reality CR10. So you can find a lot of common parts in that range. However, that being said, I have a glass build plate that I have to figure out how to prevent clipping the clips. But for reality, you can get a glass build plate for the CR10. And I think it's a 310 by 310. Again.
Oh, also 310.
What's that?
Oh, I said, also 310.
Yeah, but 310 by 310 isn't necessarily as far off as you might. It's the thing that I'm concerned about when I'm using it is how do I clip it on the bed without causing trouble? You know what I mean? I know Eric's working on getting his upgraded stuff in place.
Yep.
And I would love to be able to, like I said, I'd love to be able to figure out how to get a good clip on this without, but it's not too far off actually.
Okay. I mean, hey, the other thing too, you can take some, if you really didn't want that extra spillover from the front and back or on the sides, you could probably just take some shears and, or no, not a shears, but sheet metal, I forgot what those things are called. They operate with a giant lever.
Metal shear.
I guess they are called shears.
Shears, where everybody knows your name.
What's
What's
that?
up?
No, nothing. Very, very stupid joke. And I will not repeat it.
Damn it.
So there's that. I don't know if you see it.
Oh, I see it.
I did get my
Yeah.
7.3 maker build plate. I do have the peel and stick magnetic sheet.
Cool.
I just
Did
need
you
to
get the magnetic one, or did you get the?
No, I got the plain one, and I got the magnetic sheet from that other company.
Okay, yeah. So I think you'll like it. I have found that one of the issues with the 713 maker embedded magnet sheet, which is not a huge issue, is that it works really well with BuildTak and nothing else, because BuildTak just has stronger grippy force. Has more grippy force because of the thicker plate, and most plates aren't that thick. Anyways, the nice thing about the subtle design one is that it has a higher coefficient of sliding friction. And so the problem with the other plates, the reason they don't work well with 713 maker's design, is that the aluminum plate is so smooth that you can actually slide it around with your hand with like a single finger, relatively easily if it's not a BuildTak plate.
Yep.
So the nice thing about the subtle design one, at least the mag sheet, is that while it will take longer to heat up, you don't have that problem. Like the sliding friction is very hard to defeat, and as a result, you can use really cheap magnetic plates.
Yeah, I've got the subtle design magnet. I have not assembled this new build plate yet, but I have it.
Oh, you got one with the new cutouts then in the back.
I do.
Not the cutout, but the holes in the back.
So, what if you just took like, some sandpaper and just kind of lightly went over the surface?
That would totally work. I actually think a less destructive idea. I did think about that. I think an easier method would be just capped on tape.
Yeah, so one of the things I do with the PEI sheet is I go at it with some 4/0 steel wool.
Mm-hmm. Yeah, so I think that would. I think Eric, your suggestion would work. I figured I haven't actually.
I mean, from a PEI standpoint, that's actually one of the guidelines I've seen is if you get a new PEI sheet, you scuff it when you first get it. Clean it with alcohol.
Oh, okay.
Yeah,
interesting.
Most of the early PEI sheets and a lot of them, the less expensive ones out there are glossy.
Yeah, like the one from CME-CNC.
Yeah. So let's see who has. And I was wondering if I could get a BuildTak. Yeah. Well, BuildTak's actually behind. They're not shipping anything right now.
Hold on. Are you looking for build plates?
Yeah.
If you're willing to wait like 3 weeks, there's one from China that sells rather thin build plates. They're very thin, but they will work quite well. I'm convinced they'll work really well on the subtle design plate.
I am actually kind of thinking I would. So the ender sheets.
Uh-huh.
So they make a flexible build material with magnetic sheet, right? It comes with on the Ender Pro, Ender 3s, and Ender 5s.
Yeah, it looks like refrigerator magnet.
You can also get it for the CR10, which is 310 by 310. It's about $20 for a sheet, for a flexible magnetic sheet with a build surface on it. I don't know how well they stick to the. I can find out real quick. I got one. I'll just stick it on there and see what's up. Not great on the magnetic sheet or on the magnetic build plate. It moves around.
Oh, bummer.
Well, it on the magnetic build plate, it moves around. I bet bet you on the subtle design, it would work
Probably would work, yeah.
pretty well. But that being said, for the price that for the $20 odd you get, right? Check out the CR10 magnetic, the Creality CR10 magnetic build. And again, you just put her on there and then you trim the edges.
Yeah.
And that might work. That might actually work really well because you can get replacements for for very little money. And it looks like the sheets have like alternating rows. So the magnetic sheet underneath has what appears to be alternating rows of magnets in it, or alternating magnetic fields in it. So the cover sheet, the build sheet, has very specific areas that it will actually stick.
Interesting. Okay.
So as you go back and forth, you'll find, oh, look, it'll tend to snap into a row.
Mm-hmm.
But it's got about 15 pounds of pull weight in order to get it to move. So there's that.
Cool.
So that's a thing that might be an alternative. And those, I'll tell you, those build plates, I have found that I tend to have pretty good success with them. On the other stuff that I'm doing. CH Power Quality CR10 10S ultra flexible removable magnetic build plate. $21.
Mm.
And that includes the stick-on magnet as well as the surface. You could have one on Tuesday for $21.99. And if this works,
that's a lot cheaper. This is the Creality sticky sheet.
yeah. Let me get you a link.
Okay. I don't know. My experience, at least with the sticky sheets, is that they don't stick as well as PEI. But that's just me.
Well, it's not a sticky sheet. It's
or the build surface.
There it goes. There's a link.
Mm-hmm. Mm-hmm.
So I've used, these are what comes with the Ender 3s, Ender 3
Yeah.
Pros, whatnot. The biggest thing with those to get them to work well is to not touch them. No, seriously, don't get grease on them. And clean them if you do handle them a lot, or if you leave fingerprints on it. If you can see a fingerprint on it, you're going to have a non-stick point.
Whoa,
So
it's that sensitive.
What's that?
Very sensitive.
It's not unreasonable. I have a similar issue with some other things, as long as it's not, the kind where it's actually using the differential temperatures, right?
Mm-hmm.
Trying to adjust my Z offsets. I had so that coaster came out okay, but it definitely reflected every ripple and bubble and tear in the PEI sheet.
Yeah.
And
It's
I
a good
didn't
first
have.
start, though.
The placement of the nozzles is dead on location. All right. As far as let's put it this way, it's on location, and there's no overlap in the lines. But the issue I had was bed adhesion on the first layer in the white, because the white went down first.
Okay.
And it's trying to do infill of letters.
Yeah.
lots and lots of small, and I slowed it way down. I was doing like 30 millimeters a second on the first layer. I'm trying to adjust my Z offset so I can adjust do the G10 offsets, so I don't have to play with baby stepping. Because baby stepping is not applied to each tool individually, it's a total. Doesn't matter which tool. If you baby step for one tool and it changes tool, that baby step will be applied to the second tool.
That makes sense.
It may make sense, but it means that you're rapidly pushing buttons.
Oh, okay. That's not good. I was like, that makes sense. They designed it for monochrome printers. I believe it.
Yeah.
That was the part that made sense.
Yeah. Also, I discovered that Duet forums are not friendly.
Yeah.
Not from a standpoint of you're an idiot kind of thing, but from a standpoint of there is no category for hardware support. There's hardware, that's great. There's no category for warranty items. There's purchasing. Well, okay. So it kind of...
Ambrosia is here, but I can't hear them.
Huh? Oh.
Aaron, hey guys, how you guys doing tonight? Everybody good?
Hey.
Welcome.
How's it going?
It's going well. I have my Jubilee printing. I'm so excited.
Oh,
congratulations.
Sweet. Yeah. Do you have pictures?
Well, I sent the one of the Benchy.
Yeah.
And I mean, there definitely are some issues, but overall, I'm so excited because that was just default Simplify 3D settings. So I haven't even tweaked anything, really. And so I'm very excited.
So I think the one thing that I would mention, it looks like a really good first pass. The tower at the top, the way to fix that I fixed in my simplified 3D settings, if you go to speed overrides in the speed section, tone it down to printing speed for layers below 3 seconds.
Sorry, gotcha. I had muted myself. Okay, so feed override, printing speed below 3 seconds for layers below 3 seconds, right?
Yeah, so my default speed, so let's see, I reduced it 40%.
Eric?
My default
What'd you say, Brian?
speed,
So that looks good.
Thanks.
Yeah. Okay, so I have 40% of my default speed, which is 100, and my outline speed is 60.
Outline speed is 60? Okay. Cool.
And let me actually just screenshot this. That'll make your life better. Yeah, sorry, I mentioned I was going to do this earlier, and I realized that there was no good way. I couldn't figure out an easy way to share it, but screenshots might totally work. Hey.
I also changed all my extruders. I set all my extruders to spread cycle.
Oh yeah, do you like that more? How is that working?
Well, it seems to be working a little better. I was having lots of extruder issues. The other thing is there's apparently a known issue with the Chimeras with 16-step microstepping.
Oh.
So I may jump it to 32 or 64, or maybe down to 8. I don't know. There's some essentially some chatter in the Chimera. So
interesting.
So, but anyway, I did go to a decrease when I was defining my extruders because I've got Chimeras. But anyway, extruders shouldn't be self-stopped anyway, so may as well leave them in spread cycle. If you got it,
is that a default? Is that a default option?
That's the default for 2209.
God damn it!
So you need to
go.
For
2209. Okay, so I have the 20. I still have the other one. You're running
a duet. You're running the 51. Well, the duet 3s you got 51 TMC 5160s, which are monsters. But yeah, so my tool boards have 2209. and so I went to a D2 on them.
Hmm.
I haven't jumped the microsteps. I did do an E-step calibration on both of my Chimeras, and they're dead nuts on at 400.
So did
And
what?
dead nuts on, right on at 400 steps
Oh, great.
per millimeter. Um, I, I I checked both of them at my PLA 205, and I always, unfortunately, with the Chimeras, you've got to do your extrude through the nozzle, so you got to go real slow.
Hmm.
Make sure you're at operating temperature and then go real slow on your extrude.
Hmm.
So it's E100 F100 kind of thing. Yeah, 100 millimeters each, 3 times each, right on. Um, but I have a different flow factor for Sunlu versus Hatchbox. A different flow rate check.
Oh, okay.
So, oh, and I did move my peripherals all into their own files. So each of my peripherals has its own definition, and then the
Cool.
calibrator just calls a peripheral.
Cool. Yeah, yeah.
So you still have to you do still have to define the axes and whatnot, because I don't think I can define that outside of config G. I haven't played with it, but the issue I know the issue that we will see is that every time you make a call to define an extruder, the numbering starts over again and essentially wipes out what you had before. And thank you, I got the parts today. They arrived today.
Oh, yeah, yeah, yeah. Sweet.
It was like really fast.
I'm impressed.
Yeah, I got to see if I
Yeah.
can find little solder logs. Next time I make a DigiKey order. I mean, I'm pretty.
Oh, the default is spread cycle for 2660. Okay.
Thanks for those settings. Appreciate it.
Yeah.
What are you using for your scripts for?
Oh, yeah. Let me show you.
Starting layer. The ending script. I left the ending script and it ended up trying to go X to 0.
Oh, no.
To emergency stop after the Benchy. But yeah, it was.
Okay. Yes. That is in the wiki. Hang on. One sec.
Is it? Okay.
One sec. It's in here somewhere, and if it's not, that's bad. Printing. Oh, it's because it's not very evocative. It's in ending. If you scroll down, go to ending GCode.
Gotcha. Awesome. Oh, wonderful. Cool.
Yeah. So that's the only thing that's in mine. Actually, so Eric
Yeah.
doesn't use the. Okay, so I have a G0 Z305, which makes the bed go all the way down.
Right.
That can be. You can leave that out if you don't want it.
Okay.
I just added 20.
Yeah, 20 is probably fine.
I just did I went to a relative and then added 20 millimeters to whatever it was.
Yeah, I think that's what I kind of put in there for this print. I just put a relative move of 20, and then move the carriage kind of to then back to absolute positioning and move the carriage back so it would clear. But I was hoping to see if there was something else that I was missing. I'm a little concerned at the end of this print it's going to do something crazy or wonky. I'm new to GCode, so.
It's okay. I mean, honestly, I wish we didn't have to memorize as much as we end up memorizing.
Right. Much appreciated. Awesome.
Yeah.
That was a mess. I got distracted. Oops. You know what happens if you don't put your build surface back on your build plate?
Oh,
Your nozzle doesn't come anywhere close to it.
Oh.
It is not a bad thing. It just means that the nozzle didn't come anywhere close to it.
Well, that's good.
Yeah.
Hi, everybody.
Hello, good evening.
hello.
Note to self.
I had my first manual tool change today.
The
Nice.
cancel the job. I did cancel the job. Why are my tools still in standby? So apparently if you cancel a job, the tools just stay in standby.
You might, there's a cancel.g, a GCode script that you might be able to put it there.
I mean, it ran the cancel.g. I'm going to have to go back and check and see why, but the tools stayed in standby. So I will run a t-1 and see what happens. Nope, they're still in standby. It's all right. I'll just set my standby temperatures to 0. That'll be fine. Also discovered that if you're moving from Cura to Prusa Slicer, Cura sets flow rates as percentages. So 95% is 95 is an appropriate value for the flow rate in Cura. 95 is not an appropriate value for a flow rate in Prusa Slicer.
Ah!
And there is no sanity check. It is perfectly fine in letting you run a flow rate of 95 or a flow multiplier of 95. How's that?
The machine's off.
What's that?
Go ahead. Talking to myself. The machine is off.
Yeah.
Okay.
Hey, gentlemen.
Hello.
Hey.
Hello.
So I actually got my double fully end plates in place. The motor plates are all built. I've got to put the switch on the motor plate because the switch is so all that's going along, moving along. Actually didn't have much time to spend on it today. Josh, I will have a stack up for you.
Oh, that'd be great.
That will
For
work.
I'm sorry, that's giving me so much trouble.
You know, the thing that I found is key is this. I keep the bottoms the same as in your design as yours, right? So I use the 3 mm standoff and a 0.2 millimeter shim as the starting place, and then it's
Yeah.
only the second pulley that you then have to like get them shimmed to the right height.
Oh yes, I agree.
And so
Because the bottom plane is just the bottom plane,
right,
like the
and
pulley plane.
so what I did, and it was really hard to eyeball, but I basically eyeballed it. I would basically sit them on the plates on a set of extrusions so that I could get the pulleys side by side and then measure it. Because sometimes the when I would do the math on things and then add it up, there was either extra slop or it was too tight. Like like it was much
Oh.
easier to just be like, okay, I'm gonna put you guys next to one another, stack it up. I would say there's maybe 0.1 to 0.2 millimeters of play at the very top of the stack up,
Oh, I wouldn't
but
worry about that.
but I
I
am not
think,
worried about that.
yeah.
And at most there may be a half millimeter to or sorry, a 0.1 to 0.05 alignment difference between the middle pulleys on the top pulley on the double corner plates and then the top motor plate set up. And then I have yet to bother to figure out what it's going to look like on the crossbar yet.
Well, no, it should be the same.
It should. I think so.
Should.
I hope to God.
Yeah. Wait, so
Crossbar.
Eric mentioned that, and I also noticed this too. One of the new printed versions of the plates. I'm not sure if you're using Dalbrin ones or printed ones.
Nope, I'm using the printed.
Okay, so Eric mentioned that they may not all work perfectly, so they may be like 0.2 millimeters too thick. So, which is like the nominal, because I'm printing them at the nominal dimension. So what I'm going to do is, I think on the next rev, or even just hot fix it into the current branch, is just make them 0.2 skinnier, just so in case your printer prints them a little bit too thick, you're okay.
You're talking about the plate thickness, top to bottom?
Well, honestly, I measured some of the Gates pulleys to have a little bit of a tolerance to them as well. It's not just the printer.
Yeah.
Well,
okay,
the thing
so
is,
yeah, that'll help then.
So if your plate prints thick, okay, go ahead and just sand it down. You've got two sides. One side is flat. The other side has got a little raised surface on it. You just lap it flat. You can a couple of passes on some 220 grit will smooth it out, and you make you make some passes until it fits.
Well, that works too.
If you thin it down,
You need to thin it on the side that has the bumps, though. Otherwise, it's not going to work.
Yeah.
So,
yeah, he's right. Yeah, which is harder.
So, sure, you could do it, but it would be a lot nicer to not have to do it.
Oh,
yeah,
well, then,
I agree.
So
if that's where your error, your tolerance is.
So what's funny, Josh, is I had already made those basically because of the problems I had with alignment prior, remember?
Okay.
And what I did was I actually took the outline of the plate, made a drawing in, and I did it in Tinkercad, and I just created cylinders where the screws go through, and I could set how high the cylinders were. So it would probably be pretty easy to make that a parametric part in like SCAD.
Oh yeah, yeah.
Right. The one thing I've noticed, you know how the new plates have like a flexure to them, where the shoulder bolts go through. They have that little bit of a.
Yeah.
I've noticed that wants to twist. That makes the shoulder bolts want to kind of like twist in one direction or the other.
Oh, okay. You know what? I did notice that on one, but I didn't notice that on any of the other ones.
Yeah.
Okay, that's good. That's good to know.
So, and I think it's probably from the fact that there's, it's inflexible on one side and then flexible on the other side. So if they don't have the exact same thickness everywhere, or if there's a little, it's just going to be uneven tension.
Yep.
So I just want to give that feedback from my assembly adventures. And then I had a question I was going to ask. When I looked over and saw that everybody was on, I was kind of like, hurrah, see if anybody was interested. So I've been talking to Peter from Wham Bam.
Oh, cool. Yeah. I reached out to him a long time ago, but it's been a while.
He gave me kind of what his minimum would be.
Was it 40?
It's 20.
Oh, that's much better than it used to be.
Yeah.
That's
Is that
totally...
custom printed?
Yeah. Custom done, plate. And here's the thing. Honestly, it would lower the cost overall.
Yeah,
because
what are they priced at?
It's like $86 for for the magnet, the plate, and the PEX sheet.
Oh, I was thinking about just the sheet.
Yeah, no.
Sorry, not the sheet. Just the magnet. My bad. I mean, no, not the magnet. Just the sheet. The
sheet.
thing you print on.
Yeah, those would probably be. My guess is probably like $30 or $40.
Yeah, if they're comparable to BuildTak, like thickness-wise, it would be awesome.
So I actually compared my existing little sheet that I have to what I get with the BuildTak, and it's it's stronger.
Oh, really?
It's stronger than the BuildTak one.
That's awesome.
And the magnet, I've compared the actual like magnet sheet too, and if I was, in retrospect, if I knew that was available, I would do a Wham Bam with the magnetic, their pad. Their pad goes up to 150C.
Mm-hmm.
For and pretty much that's the practical limit, I would say, of the printer right now, right?
Yeah, I agree.
150C. You're above that, you're into like samarium magnets and other crazy stuff, right? So that's one thought, is for that much, you can get the bed for $70 right now at 713. At 713, right?
Yep.
And then $80, let's say, for the Wham Bam kit. You're at $140. You're basically less than the price of just the bed from anyone else. So I think that's a good budget option.
So you can already play this game a little bit, not entirely, but if you get a vanilla build plate with a subtle design,
right?
Mag sheet. That so far also they actually sell 305 by 305. They actually already do that, which is cool.
But they don't actually have any build plates, by the way. They're out of stock, completely out of stock on the subtle design site.
Right. So, but again, here's another stock issue. CNC's build plate works great on the subtle design magnet, and that's a $30 plate. So that would be another way to do it, just to configure the bomb, because then you drop like another $50.
Yeah. And my actual concern with the mag plates, after having looked at mine and all that, they're not going to heat very evenly with all the magnets in them, and the void of the space between the air gap that you have between the silicone sheet and the heater and the magnet, and the fact that magnets, they're not going to conduct. They're not thermally conductive, right?
If someone's willing to send me a flare camera, we'll take pictures of a magnet sheet.
Yeah.
So I have the 713 vanilla bow plate and the subtle design magnet.
Yeah. And
I need a flex plate to go on top of it.
What's funny is
you can borrow one from Home Depot. You can check it out for the weekend.
What?
Not kidding.
You can?
Yeah, you can they have a tool checkout, and a FLIR camera is on their list.
Okay. Well, they weren't renting anything at my local Home Depots.
Oh, maybe it's or maybe it was Lowe's. It was one of those two big box stores.
I mean, normally rent stuff. Their rentals are pretty much shut down right now.
Oh, okay, that's the other thing too.
But yeah, so I talked to him about it. He is basically willing to do it, if we can get the volume up.
Just the plate would be a win.
Yeah.
Okay, so
with the plate.
here's the way to do it. Oh, go ahead.
Yeah.
Everyone else is. One way to do it would be I can just ask Tim to place the order.
Tim
And
from
start there. Philistruder.
Philistruder?
Yeah.
Yeah, I gotta call Tim next week anyway, or shoot an email.
You think he would go in on
20 met plates? Oh yeah.
20 plates?
Yeah. Oh yeah. Especially
Okay.
because the long-term plan is to maybe stock kits, Jubilee kits.
Okay.
And so he's not losing anything in the short term if he doesn't sell them in 6 months.
And the other thing
and then
is,
of course if I put it in the bond, then people are going to buy it from there.
people are going to go buy it, right? Yeah.
Yeah.
Yeah, that was kind of my thought.
Those plates, I would get two right off.
Yeah, I was the thing I hate. I've got the build tack plate. I hate
Same.
the fact that there's no tab.
Oh, that too.
There's no tab to get the damn thing off the bed. And
Yeah.
I was messing with it the other night, and I put the plate and I squared it up too well before I put it down.
Mhm.
And then I'm like, okay, well now how the hell do I get this up without scratching up the aluminum plate?
Mine's already
Man.
And then that build tack plate has a razor frickin' edge. They didn't burr it at all.
Yeah, I had to
Oh, I
deburr
thought that was a problem with all of them. Oh,
Yeah.
This is good to know. I didn't realize that was not the case in general.
Yeah, no.
Yeah, in general, they don't. Yeah. Oops.
Yeah.
Are we laying down filament?
So, but other than that, I haven't been up to too much. I assembled my other ender yesterday and found the things that were broken from the returned ender. Whoever had it did attempt to use it. However, they broke a limit switch, and then they installed the PTFE tube for the Bowden tube was installed improperly into the nozzle, so that there was slack in it where it would move, and it wasn't. It was one of those where the coupler itself was now moving, like the internal jaws of the coupler, and I couldn't get the PTFE tube out. It was stuck on both ends, because it had flared. So I ended up basically cutting one end and pushing it through the opposite end on the other side, and then just I've got replacement parts coming tomorrow, in fact. But yeah, nothing was majorly wrong with it. I will say the thing I have become impressed with enders is just how horribly they can be assembled, yet how reliably I can get them printing. It's ridiculous. It's like, oh, this isn't straight, this doesn't work, this is misaligned. Well, just tweak this, and all the predictable problems were there. They had messed around and trying to tighten the eccentric nuts and completely gotten it messed up. So that was kind of the crazy thing, but I've got it all working, and I have parts coming tomorrow, and it's all going to be working.
Yeah, so the first one I got, you saw the pictures of it.
Yeah.
I replaced the end stop and I had to turn some extrusions around because there were dents in the extrusions.
Yep.
And I will eventually have to start replacing a few of the wheels because the wheels were actually chipped.
Yeah.
It had been slammed around so much. But saw the picture of the cat, the test print,
Yeah.
that I posted, that came off of that ender. All right.
Yeah.
I have done something and my offsets are not reading properly. So it's time to do the offset again.
Well, hey, I'm actually going to drop off. I'm grabbing a snack with the fiance, and if I'm done with that and you guys are still around, I might come back.
Have fun.
So if not,
Have
everybody
a good one.
Good night.
See you.
Yeah, so for what I have no idea what I did is I increased the Z offset. And it should have put the tool closer to the bed, but it did not. So maybe I went the wrong direction. It's alright. I can do this. Right?
Yes. Yes, you can.
Yeah, this is always so much fun. Where's my paper? Better Z tool or better Z methodology. I know Daniel's working on it. Z is minus 1.3. That works. So what's everybody working on printing right now?
Parts for the Jubilee.
Standoffs for the duet motherboard.
I'm actually doing what is it's a spool, the tabletop spool holder. Somebody sent the link in Thingiverse in one of the chats. I realized I didn't have any place to put the spools while I print parts for the Jubilee, and so here I am slowly, manually, just making sure that the spool just kind of, unspools as it's printing, like a caveman.
Oh, no, you're fine. Minus 20.
Yeah, the ultimate spool holder, the Tush. The one with the
There's another one that I've got that works really well.
Yeah.
Give me a sec.
Yeah,
I gotta
send it.
put this entry in my T offsets while I'm got it in front of me. Otherwise, I don't want to forget it.
Yeah, no worries.
Because I'm doing offsets.
Okay, so this thing, press the
Okay.
button, and you just turn. Sorry, was my mic on? Sorry.
Yeah, that's all right.
I got one of those $70 screwdrivers. The one with the accelerometer in it.
Yep.
I really like that thing. What is it, the ES120 or something like that? I got the ES120 Plus for like $80.
Aha.
There we go.
I have that same one on my under 3 right now.
Like, thanks for the link.
Can you hear me now? Finally, my audio died.
Oh, we thought you just were ignoring us all.
No, I had no idea that. I was like, no one can hear me. No one's responding to what I said. But I was like, well, maybe they were busy. And then I was like, wait, no one's. That looks great. No, I guess like my audio. My microphone is disconnected. Oh yeah, I was gonna say, Brian, if you, I actually must say I really
Your microphone is also acting weird. There we go. So you were saying?
The balls in the stringy coil trick. I installed them, and there's like noticeably less resistance on the motor.
Really?
Yeah. So I'll run it like this.
Yeah, no. By all means, if that's gonna
It is much smoother.
It is smoother? Okay.
Yeah.
That's okay. What did you see my PSA earlier today?
Maybe.
I don't remember where I posted it. I think it was in random.
Oh no, it happened.
It's like I'm hearing some funny noises from my machine, and I look over and I see two of the screws have rattled themselves loose on one of my Z motors.
Oh, did you not thread lock them?
I apparently had not used enough thread lock, or I had
okay.
in a position I had thread lock far enough up. And I'm like, well, that's odd. So my motor was actually had twisted in the frame. So I went back and pulled all the screws one at a time and re-thread locked them and put them back in and smoothed everything back down.
I remember.
Everyone all right?
I think we're all spotty. Maybe it's a Discord problem.
I'm back.
I don't think it's you. I think everyone's spotty.
Okay.
I'm gonna blame Discord.
When in doubt, blame Discord. Once I'm done and this is production ready, it's going to get put someplace, and the spools are going to get hung up in a rack above it. But I'm running a load cell. I've got a bunch of these spool holders with load cells on them, and I had them going to an Arduino that was feeding just basically it was a scale that you could see how much was on the spool at any given time. So you throw an empty spool on it, you hit the tare button, and then you hang your spool on there. And anytime it's idle, you can get a reasonably accurate reading of how much filament's still on the spool. Load cell's like $6 or something like that. The only thing I have noticed is that with the bearings on that particular mount, your spool unwind can be a little bit excessive. It's really freewheeling. Your spool has got very little friction on it.
Not normally a problem that I hear about.
What's that? It's not really a problem.
No, it's not normally a problem that I hear about. It's too little friction.
Actually, I've had issues where it's tugged on the spool, and the spool has unwound enough that it's dropped the loop.
Yep.
So that can be a problem.
Wow.
Ah.
Man, I need a table. Working on this on the floor is not easy.
Yeah, wait till you're 50 plus.
Why don't you just get one of the little plastic ones?
Get a table. So I told myself I was going to spend tonight this weekend making myself a pipe table, and that's probably not going to happen for another couple of weeks.
I tried to make one of those rewinding spools. Have you seen those? It has like the slip clutch in it.
Yeah.
I could never get the damn slip clutch to work.
What is the benefit?
Go ahead.
Oh, well, no, you can explain it better than me.
It's
basically it takes the slack out of your filament. So for me, it was when I was running 3-into-1 color changes, I have to back filament out 180 millimeters. And all that slack could cause the filament to come off the edge of the spool or whatnot. So this is sort of like an adjustable clutch that as you back filament out, it winds it back onto the spool.
Okay, got it. Cool.
It was designed by Prusa for the MMU2.
That makes sense.
So when they backed out the filament in the MMU2, it went back. You didn't have the spool hanging out in space. So, all right, I think my offsets are actually in pretty good shape right now. So the Delrin plate, the Delrin locking plate, it definitely locks up better than the plastic one.
Yep, agreed.
Oh my gosh, so much. However, and I did print mine at 0.1.
Yeah.
I think I'll try to print another one at 0.05 and see what I can get with it.
Okay.
But the 0.1 plate that I have is pretty smooth on the ramp.
Mm-hmm.
But it catches during the lockup.
Yep.
And then it snaps into place. You hear the little catch, and then it finishes the rotation.
Mm-hmm.
And locks in. So that's all right. So
I realized why I'm changing my microphone settings when my arm touches the side of my head. I'm leaning on the ground on the machine. Okay, yeah. As far as wedge plates go, I have the Delrin is basically going to be, I think, the long-term solution. I've kind of settled that. I waited a week to get a second quote on the Delroom plates, but I think we're gonna do the one with the $1,000 mold. And I think I was explicit enough as to where the drop handles are supposed to go that I think it should be okay. If it doesn't work, a lab will absorb the cost, which is actually incredible.
Who will?
What's up?
Who's doing it?
Oh, someone in China that I met on Alibaba.
And they're working out the draft angles?
No, I did it for them, but I didn't actually. I waited I got the quote, and then I waited because someone on Discord reached out to me and said, "Hey, let me look around a little bit more." But I don't think they found anyone else who was cheaper.
Okay. And what are you using, a 1% draft? Or
It's a 1 degree draft, yeah.
Okay. And which way is are you using a flat mold or are you splitting it? It's flat mold, right?
It's 2 pieces flat, yeah. It's just
It's flat on one side and then it's indented on the other, right? Or are we splitting the part?
Almost. The center piece has a little bump, would have a little bump in the middle, but I'm gonna have to work with them to see, because I'm not actually doing the mold, I'm just modifying the part such that it's super obvious how they would do the mold.
Okay, yeah, because the mold is. Have you tried Protolabs?
Steve quoted through them. I think they were still a little bit. They were like order of magnitude more expensive, I think.
Well, one of the things they also do is they'll have it to you in 3 days.
There's that too.
And for small runs, though, they're also doing injection molding with 3D printed molds rather than doing a ESD mold, machine mold. So that's a thing. I don't know what it takes to injection mold Olin. But that's a thing. So
yeah, I'll keep it in mind. It would be a good backup.
Just from a standpoint of your total production too.
Yeah. No,
if they're
it would be nice to get. Oh, what's up?
If they're going to give you a good price, usually a mold is not cheap.
Yeah, and the price was $1,000 for the mold.
Well, $1,000 per mold is actually cheap. I've done some mold quoting for miniatures, and I made molds for miniatures, spin cast and lab computers. Also spin cast and resin. All right, there's plastic going down. And it looks like it's sticking. I don't need a spacer. What? No response? Jeez.
I think we're all muted. Congratulations.
No. I said the word.
Spacers.
I think did I disconnect again? Oh no,
and they ate Robin's minstrels, and there was much rejoicing. Yay. So definitely if you're moving between Prusa and Kara, as far as slicers are concerned, make sure you look at any variation in what they consider an extrusion factor. Percentage versus an actual number. Oh.
Okay, we're good to go. Let's turn this on again.